We're going to talk now about the notion of antiderivative. We've seen that if we have a function, then we can take its derivative, which at every given point, it is the slope of the tangent to the graph at that particular point. And we saw that for polynomials, we know that for polynomials, it's pretty easy to find the derivative. So for example, if you have something, let's do a generic example. If you have something like 5x cubed plus 4x squared minus 6x plus 7, then the derivative can be found simply by taking the derivatives of the corresponding monomials. The constant has derivative 0, so we don't even have to worry about this. So the derivative of x cubed is 3x squared. The derivative of x squared is 2x. And the derivative of x is 1. And then multiply those with the numbers in front, with the coefficients of 5 plus 4 times 2x minus 6 times 1. So if you like, the final answer here will be 15x squared plus 8x minus 6. So for reasons that are going to become obvious later, right now, actually, it might seem very, very strange and doesn't necessarily make any sense. But later, we will realize that the following notion is of great use. Finding a function whose derivative is a given function. Meaning, what if somebody told you, what function did you take the derivative of in order to come up with 4x cubed minus 3x squared? Okay, so can you guess what was the function whose derivative is 4x cubed minus 3x squared? And the idea here is, I think just by inspecting this particular function, it wouldn't be too hard to take a guess. So what gives you 4x cubed? That's exactly the derivative of x to the fourth. And what gives you 3x squared? That's precisely the derivative of x cubed. So the answer here would have been x to the fourth minus x cubed. Plus, please note that you could add any number you like. So you could say plus 1 or plus 17 or plus 173. I don't care, anything you would like. But in most cases, we will not want to add this additional thing because it's not really needed. So the answer would be this. However, if somebody gives you something which is not that immediate to guess, so for example, they tell you not 4x cubed minus 3x squared, but rather x cubed minus x squared, then you have to do a little bit more thinking in order to figure out what the correct answer is here. So first of all, the function whose derivative is a given function will be called the antiderivative, or an antiderivative for that matter, since we said there are more than one. So for example, here the correct statement to have made is that an antiderivative for 4x cubed minus 3x squared is given by x to the fourth minus x cubed. So now let's go to the situation that we were just describing. What if somebody tells you what is an antiderivative for x cubed minus x squared? In other words, what function do you need to take the derivative of in order to find x cubed over x squared? So here's how we think about this. Well, to come up with this x cubed, you must have taken the derivative of something that has x to the fourth, right? Why? Because when you take the derivative of a monomial, the power goes down by 1. So if you want to acquire x cubed, somehow x to the fourth must have been involved. But if you take the derivative of x to the fourth, you find what? You don't find x cubed. You find 4x cubed. So the question is, how can you get just x cubed? And the answer is that you have to anticipate this 4 that will show up in front and just get rid of it by having multiplied with an appropriate number. So, for example, if I have a 1/4 here, when I take the derivative of 1/4, then this will be 1/4 times 4x cubed. And you see now the 4 will cancel with the 4, giving you a nice x cubed. And how about x squared? What if you want to obtain just x squared? Then again, you will have to start with something like x cubed. But you know that x cubed, when you take its derivative, is going to give you 3x squared. So you want to multiply with something in advance that will rid you of that 3, and that would be 1/3. So indeed, this would be x squared. So here, the answer would have been 1/4 x to the 4th minus 1/3 x to the 3rd. And now you could, let's do one example like this. So find an antiderivative. For x to the 5th minus x. Okay. Please pause the video and try to do this. So in other words, we're looking for what function should we take the derivative of that will give us x to the 5th minus x. Okay. So pause the video, and here's how we do it. So the answer here will be to get x to the 5th. Again, you have to start with x to the 6th. Anticipating the extra 6 that you're going to get, you should divide by 6, meaning multiply by 1/6. As for the x, you should start with x squared. Of course, if you take the derivative of x squared, that will give you an extra 2. And anticipating that, you should put 1/2 in front. And of course, you can try it. I mean, every time you do something like that, you can actually verify it by taking the derivative and seeing if you get exactly what you were supposed to get. So here, what are you going to get? 1/6 times 6x to the 5th minus 1/2 times 2x. You see this cancels with this cancels with that, and it gives you x to the 5th minus x, which means that it works perfectly as it was supposed to. So in general, to give a general formula that will help us, whenever we're looking for the derivative for the function whose derivative is x to the n, the answer is take 1 power higher and actually divide by that power, by that exponent. Which means that whenever we have a general polynomial, so whenever we ask what function would give us the as derivative 5x to the 3rd minus 7x squared plus 6x plus 2, then the answer is what? We should take the antiderivative for each of the monomials and then put back the coefficients. For this one, you can always think that 2 is multiplied by 1. So what is the antiderivative of x cubed? It's x to the 4th, 1/4 x to the 4th. What is the antiderivative of x squared? X cubed divided by 3, or 1/3 x cubed. What is the antiderivative for x? 1/2 x squared. And what is the antiderivative for 1? Simply x. Now put back the numbers. 5 times 1/4 minus 7 times 1/3 plus 6 times 1/2 plus 2. And you can simplify this a little. You can rewrite it as 5/4 x to the 4th minus 7/3 x cubed plus 3 x squared plus 2x. And that's our answer. Okay, let's see if you can pick up this faster way of doing this. So as an example, find an antiderivative for p of x is equal to 8x to the third minus 7x squared plus 10x minus 5. So please pause the video and try to find the answer to this. And now we can check it. So the antiderivative, let's denote it by capital P of x. You will see many times we play this game whenever we have a function. We denote the antiderivative with a corresponding uppercase letter. So the antiderivative of x cubed would be 1/4 x fourth. When you multiply, so let's write them underneath so that you can see them. The antiderivative of x cubed is 1/4 x fourth. The antiderivative of x squared is 1/3 x cubed. The antiderivative of x is 1/2 x squared. The antiderivative of 1 is x. So when you multiply them by the corresponding coefficients that you have in front, what do you get? 8 times 1/4 gives you 2x to the fourth minus 7/3 x to the third plus 10 times 1/2 is 5x squared minus 5x. And that's it. Okay. Let's do one more. So find an antiderivative for p of x equals 9x to the fourth minus 5x cubed plus 3x squared plus 7x minus 4. Okay, so again, let's pause the video and try to do it. We'll give you a couple of seconds. And let's see, the answer is what? So again, try to figure out the individual antiderivatives for the monomial. So for this, it's going to be 1/4 x to the fourth. For this, it's going to be 1/3 x cubed. For this, it's going to be 1/2 x squared. And here, you're supposed to CN1, and it's going to be x. So now multiply by the corresponding numbers in front, and you should get the answer. And the answer should be 9/5 x to the fifth minus 5/4 x to the fourth plus 3 times 1/3, that's 1, so just the plain x cubed, plus 7/2 x squared minus 4x. And that's all. Okay. Thanks for watching.